Hello everyone, today we're going to be talking about graphing radical functions. We're going to talk about square root functions and cube root functions. Okay, notice that the square root function is of the relation y equals the square root of x. So this is real simple. Basically, you're taking the square root of whatever your x values are and you're finding your output, your y values. So here you'll see the parent function's already graphed. You'll notice when x is 0, square root of 0 is 0. Right? Square root of 1 is 1. Square root of 2 is not a nice number, so we go to the next perfect square, which is 4. Square root of 4 is 2, and then the square root of 9 is 3. So you always want to try and do your perfect squares. Those will be your best bets because they have nice numbers. Now, with square roots, notice that we don't go over the negative values. You can't take a square root of a negative value because you have your imaginary functions. So what this means is my domain includes the 0 value, right? And it goes all the way to positive infinity. Okay, so that's your domain. Range, same concept, starts at the 0 value and then goes all the way to positive infinity. Now there will be times when we do have negative numbers, and that's when we have reflections, and we're going to be talking about that in a second. So, and transformations. That's a square root function. Okay, real simple or easy. That's a parent function. This is the cube root function. Looks slightly different. You'll notice we're talking about cube root now, so it's not square root. So again, this relation is y equals the cube root of x. Okay, and then now when we do this, we got to think about the perfect cube roots. So with perfect cube roots, we can have on both sides. Okay, because you can take the cube root of a negative number. Like let's start with the cube root of negative 8, right? The cube root of negative 8 is negative 2, and then so forth and so on. We can basically mirror each other, right? Cube root of negative 1 is negative 1, 0, 1, and 2. They kind of mirror each other. So you'll notice that this is a lot different than that one because we do consist of negative numbers because it's a cube root, not a square root. So your domain is going to be infinity, negative infinity to positive infinity, right? Which we should all know this means all real numbers. Okay, a range, the same thing, negative infinity to positive infinity, which again, all real numbers. So your parent functions for cube root functions is all real numbers and your domain and range. All right, so I've already kind of graphed the points here for graphing. Notice these types of things. These are going to be what we call transformations, and we talked about this earlier in the piece. So my parent function would usually start here, but then I'm going to go right 2 and up 3. Okay, it's like a transformation. You want to treat this as if that's the parentheses, right? Remember we used to do that back in the day? Okay, so from the parent function 0, 0, we go right 2, 1, 2, up 3. And that's how we did it. We did every single point like that. Okay? So you'll notice that the domain and range is different here because we shifted. Okay, shifted right 2 and up 3. So my domain is going to start from 2 to positive infinity. Okay? And it includes that 2 value, so remember to use your bracket, okay, because it won't want to include that 2. My range, on the other hand, is going from 3, because remember, range is y values, so 3 to positive infinity. And that's how you do your domain and range whenever you have a transformation. Okay, here I did the same thing. I already plotted the points. We're shifting, same thing. We're still, even though it's a cube root function, right, we're still shifting the same exact way, right 2, up 3, and we shifted everything here. And notice nothing really changes here as far as domain and range. Your domain and range is all real numbers. Okay, so nothing's really changed there. We just shifted, and that's really what we're talking about here on this next page. Remember this, we did a lot of this. We're treating the square roots and cube roots as if they're parentheses. Make sure, remember, if they're parentheses, inside the parentheses is opposites. Opposites lie, right? So use your parentheses, right? Use it as if the square root was your sets of parentheses, so that you can see that you have a horizontal translation, vertical translation, reflection, horizontal stretch or shrink, and a vertical stretch or shrink. Okay, and usually we use the word compression, so you might hear me say that. do yourself a favor and pause a minute here to read these over or use your notes to go over. Okay, I'm going to go down here to these two examples I've already graphed. Okay, notice that this -2 is outside. This is going to give us two pieces. It's not just one transformation, it's actually two. So first of all, the negative tells me that it's a reflection. Okay, and since it's a reflection it's on the outside, it's a reflection over the x-axis. Okay, this is the one you want to make sure that you pay attention to because it's going to look a little bit different. And not only that, but it also has that 2. That 2 is going to give us what we call a vertical stretch of 2. Okay, so I reflect everything. This reflects, but then I gotta do a vertical stretch of 2. Well, what's going to happen is I'm going to take my y values and I'm going to multiply them times -2 to get my new y values, right? So these are going to be my new y values. 0 times -2, right? So I'm making my new table. Here's my table from the previous. 0 times -2 is 0. 1 times -2 is -2. 2 times -2 is -4. Okay, and now I can create my new y values because of my transformation. Remember, we did this earlier in the year. So 0, 0, 1, -2, 1, -2, and then 4, -4. So 1, 2, 3, 4, 1, 2, 3, 4. And there we have it. There's our new transformation. It's been a reflection. Now remember the domain, or this one, our new one, okay, still starts at the 0 value. So it's 0 included all the way up to positive infinity. Okay, this one, my range on the other hand, notice it's going down. So it's actually going to start from negative infinity and it's going to go all the way till it stops at 0 and it includes it. Notice this goes different because it's been reflected. Okay, so there's your domain and range. Okay, and then the cube root function, very similar, same exact stuff. So it's going to be this one's going to be a reflection over the x-axis and a vertical stretch of 2. I already graphed the parent function here for you. I have made the table here for you for this cube root. This is your table. This is what I'm going to start with. Okay, then I'm going to do my transformation. Okay, my transformation is a reflection over the x-axis, right? Reflect over x. And a stretch of 2. Okay, so again, just like we did before, we're going to take my y values and get my new y values by multiplying them by -2. So -1 times -2 is positive 2, 0 times -2 is 0, 1 times -2 is -2. And when we plot these points, you'll be able to see that this reflection here, okay, and the stretch. Okay, so my first point's -1, 2. -1, positive 2. My second point, 0, 0, of course, the origin. And my last point is 1, -2. And here you can see your reflection and your stretch. Your domain stays the same, all real numbers because it's going from left to right. Your range is all real numbers because it's going from bottom to top. Real simple, real easy. Again, pause when you need to. Okay, make sure you use your table of your parent function and then do your transformation. Have a good day.